All right, let's dive into something that could seriously be one of the biggest breakthroughs in AI we've seen in a long, long time. We're talking about a solution to a massive, super expensive bottleneck that has been holding the entire field of AI back.
So let me just start with this question. What if the one thing that makes AI so powerful, its ability to process just insane amounts of information, what if that was also the source of its biggest, most costly weakness? It sounds like a paradox, right? Well, that's exactly what we're going to unpack today.
And that leads us right into the first big problem, the absolutely mind-blowing costs of getting an AI to think for any serious length of time. And believe me, this isn't some small issue. It's a fundamental wall that's been stopping progress in its tracks.
So here's the core of it. When you ask an AI model to follow a really long, complex train of thought, the cost doesn't just go up a little bit. Oh no, it scales quadratically. That's just a fancy way of saying the price tag skyrockets so fast it becomes practically impossible to do any really deep, long-form reasoning.
Let's break that down. Imagine you tell an AI, okay, I need you to think about this problem for twice as long. You think you'd pay twice the price, right? Wrong. You end up paying 4 times the cost in raw computing power. You can see how this gets out of control, making deep thinking just way too expensive for almost anyone.
But what if there is a way to just shatter that brutal scaling law? Well, that's where this brilliant solution comes in. It's called the Markovian leap, and it is such an elegant idea that completely changes the game by teaching the AI to just focus on what it's doing right now, not its entire long history.
And this leap is all thanks to a framework called Delethink. The concept here is just, it's genius in how simple it is. Instead of forcing the model to carry the heavy baggage of every single step it's ever taken, you just teach it to think in these nice, manageable chunks. And after each chunk, it only has to remember a tiny little summary of its progress.
So, how does this actually work? Well, it's this beautiful, logical 4-step loop. First, the AI thinks, but only within a fixed size window, say 8,000 tokens. Then, it boils down all its key insights from that window into a really compact summary, a textual state. And then, and this is the wild part, it just completely resets everything. It forgets all the little details. Finally, it just repeats the process, starting the next phase of thinking using only that tiny summary as its guide.
And the result of all this? The AI just completely sidesteps that insane quadratic cost explosion. The compute cost now grows linearly. You want to think twice as long? You pay twice as much. Simple. And the memory usage? It stays totally flat, totally constant, no matter how long the AI thinks. I mean, this is a total game changer.
Now look, this isn't just some cool idea on a whiteboard. The results are in. And the numbers, well, they are absolutely staggering. Let's look at the proof, because this is where it gets really exciting. First up, a 75% reduction in cost. Okay, to put that into perspective for you, a really complex task that would have taken 27 months of nonstop computing time on a top-of-the-line NVIDIA H100 GPU now takes just 7 months. That is a ridiculous amount of time and money saved.
And it's not just the money. The framework uses 70% less memory. This is huge. I mean, memory is so often the biggest bottleneck when you're trying to run these massive models.
And to round out this incredible trifecta, it's also 40% faster. So let's get this straight. It's way cheaper, it's way more memory efficient, and it's quicker. It is a win, and another win.
You can really see the performance gap here. The older methods, like this one called long coat, they just hit a brick wall. They fizzle out around 24,000 tokens of reasoning. But Delethink? It just keeps on going, scaling all the way up to 140,000 tokens in this particular test. It's not even a fair fight.
And you know, this isn't just for some giant mega corporation with a billion-dollar model. Get this, a pretty small 1.5 billion parameter model using this technique scored almost 50% on the AMIE. That's a really tough university-level math competition. That level of performance from such a small model is just incredible.
So yeah, the numbers are fantastic, but what does it all actually mean for us, in the real world? Well, this breakthrough basically unlocks the door to having smarter AI everywhere.
So why does this matter so much? Well, for one, it means powerful AI reasoning doesn't have to live in a giant data center anymore. We could have it right on our phones. It makes it affordable to tackle ultra-long problems, which could open up whole new avenues for scientific discovery. And maybe the best part, it works with a lot of the models we already have, right now.
As Phani Bhushan Athlur, the author of the post that inspired this whole explainer, put it, this is revolutionary for resource-constrained edge AI deployments. Edge AI just means putting powerful AI on devices that are out in the world, your car, a smart camera, a factory robot, without them needing to be constantly connected to the cloud. This makes that a real possibility.
And here's maybe the most important piece of the puzzle for getting this out into the world fast. It has zero-shot compatibility. That basically means, for a lot of models, you don't have to do any special, expensive retraining. They kind of already know how to think this way. You can just start using this method today. It just works.
When you put all this together, it points to something way bigger than just a clever new trick. We are genuinely looking at a fundamentally new future for how we build and how we use artificial intelligence.
And you know what? That future might not be about the brute force approach of just endlessly building bigger, more expensive models. Instead, the real path forward seems to be about designing smarter, more efficient architectures, just like this one. It's about working smarter, not just bigger.
Which leaves us with one last massive question to chew on. If this new technique opens the door to million-token reasoning, letting an AI think about a problem for an incredibly long time without bankrupting you, could that be one of the missing keys to unlocking true AGI-level problem-solving? It's a pretty wild thought to end on.